kind of like we have our laws of exponents, right? Like you guys knew that our laws of exponents said when you multiply, you add your exponents, or when you divide, you subtract your exponents, right? We also have some similar rules for logarithms, which allow us to rewrite things and hopefully simplify them in whatever way is best for us, okay? So, it says all of these rules are true as long as m and n, which are going to be used throughout the rules, are representing positive real numbers. So real numbers mean they can't be like imaginary numbers, right? So as long as they're positive real numbers. And also b is my what? Base. Your b has to also be a positive number. So your base cannot be negative. That's important. Our base cannot be negative. And it needs to be something besides just 1. Okay? So keeping that in mind, the first law says that if you have log of any base b, remember b is going to be something positive, of m times n. We know that's multiplication because they're right next to each other, right? It says you're allowed to rewrite that as 2 separate logs separated by addition. Okay? Now it is important that if we were to separate them out, that you now write a log in front of m and you write log in front of n because we've separated them, right? They are still both log of that common base. We've just rewritten it in a different form. Okay? So sometimes they're going to ask us to expand, which would mean to take something simplified like this and turn it into this. But sometimes they're going to ask us to condense, which would mean to take something expanded, turn it into something simplified. So we need to know both ways. So multiplication can be rewritten as addition. All right? Okay, number 2. This one says if you've got the log of m divided by n, so this time we're dividing, it can be expanded and rewritten as subtraction. Or it can be condensed, changed from subtraction back to division. Again, it's going to be important that you write log in front of both of them because they were both originally a log of that particular base. So division can be rewritten as subtraction. Okay? Rule number 3 says that if you have log base b of m written to be log equal to log base b of n, so if these two things are written to be equal, then that must mean that m and n are equivalent. Okay? No matter what they say they are. They might say m is x squared, and they might say n is 25. Well, that must mean x squared equals 25, right? Okay. Rule number 4. This one is one of those things we're allowed to rewrite as, kind of like rules 1 and 2. It says log base b of m raised to some exponent k can be rewritten as taking this exponent k and pull it to the front right here, kind of like a coefficient. Okay, so you can rewrite an exponent as a coefficient, or you can rewrite a coefficient as an exponent. Okay, but we're talking coefficient in like as in front of the log. Got to be in front of the word log. Okay. And then our 5th and final rule we're going to talk about is the change of base formula. So you'll see later on in today's notes where this is useful. But it says if you have some normal logarithm, right, with some base b, you can change it to have any base you want. Okay? Of course, nothing negative because our bases can't be negative. But you would change out this base b for any number you want. So you can see they changed it to just some letter a. And when you do that, you rewrite it as division. The m, the thing you were taking the logarithm of, is going to go to the top. And the b, your original base, is now going to be what you take the log of in the bottom. Okay, but again, I can use any base I want to use. Okay? So, 5 rules. I'm allowed to rewrite multiplication as what? Addition. I can rewrite division as subtraction. Good. If I have an exponent, where can I rewrite it? In the front, like a coefficient. Very good. And then this one just says these two are equal, then m and n are equal. And then we've got our change of base formula down here. Okay? All right, so keeping that in mind, it says for number 1, we're going to express terms of log m and log n. So instead of being a condensed version like it currently is, we want to expand it out. Okay, well, in this expression, we have division, right? Well, you guys said we're allowed to rewrite division as what? Subtraction. So I'm going to rewrite this as log. There's no base, so what's our base understood to be? 10. Very good. So you don't have to write it. Of m minus log understood base 10 of n squared, right? Okay, so we rewrote the division as subtraction. Do you guys see any other rules from up there that we could maybe use to expand this any more?
Move an exponent to the front.
Yeah, we can take that exponent of 2 and move it to the front of that particular logarithm as a coefficient. Okay, so then I would have still that log of m first, but now I'm going to have minus, I'm pulling the 2 to a front, like a coefficient, times log of n. Very good. So this would be its most expanded form that we could get to. Okay, so we've now expanded. In the next section, it says express it as a single logarithm, or if possible, maybe even get it down to just a number with no logarithm in it. So basically condense it as much as you possibly can. Okay, so on number 2, we've got subtraction. What did you guys say I can rewrite subtraction as? Division. So because of this subtraction right here, I'm going to rewrite. Do they have the same base? Okay, so we can use our rule. So log base 2. What's going to go in the numerator of my fraction? 48, And what are we going to put in the denominator? 27. What should go with that 27?
To the power of 1/3.
Right. We had this coefficient of 1/3. So like he said, we're going to pull that and make it an exponent of 1/3. Okay. What does an exponent of 1/3 actually mean?
Cubic root.
Cube root. Very good. Okay, so let's rewrite it as 1. So this is log base 2 of 48 over the cube root of 27. Well, can we take the cube root of 27? Yeah, what is the cube root of 27? 3. Okay, so this is actually log base 2 of 48 over 3.
That's what, 16?
Yeah, that divides. Okay, so this becomes log base 2 of 16. All right, that's pretty simplified. But this actually looks like what we were doing yesterday, right? And we're able to figure out what this might be equivalent to. All right, that's when we made our little box yesterday and we tried to figure out what would make sense. So remember, it was your base, which in this case is 2, raised to the we don't know power, supposedly is going to equal 16, right? So what do you guys think? What should be in that box? 4. So we actually were able to simplify this down to a single rational number 4. All right. Okay, let's do another one where we're condensing. All right, what do you guys notice about number 3? What are some things we should notice? It's got what? Okay, it's got parentheses. It has addition. Okay, so what does addition mean? Multiplication. Okay, what else we got? Subtraction, which means division. Okay, and she pointed out there was a parenthesis. What exactly is the parenthesis there for? Right, because it's all raised to 1/2 power. Because that was a coefficient of 1/2, we know that's actually an exponent of 1/2, right? So all of this is raised to the 1/2 power. Okay, They do all have the same base, so we can do exactly what you guys said. So we're going to start with rewriting our multiplication and division. So what did you guys say we should be multiplying?
M and N.
M and N. So in my numerator, I've got M times N. All right? And what am I dividing by?
P.
P. Very good. And we said all of it, M, N, and P, is all raised to what exponent?
1/2.
1/2. Very good. Now, we know 1/2 actually means square root, right? But this time, M, N, P, those are not numbers, right? Not like over here when we had the cubed root of 27. So I can't actually take the square root of M or N or P. So that wouldn't be helpful for me to rewrite it. So this is it. This is all we got. Too many variables there for us to try and solve for any. Okay, so we know how to expand. We know how to condense. Let's flip it over on the back and see if we can use some of our rules from yesterday and today to help us simplify and find missing terms. All right, so number 4 says ln of e to the 4th. Okay, so yesterday, remember we were always looking for what it was equal to. We put like a box there. You can put whatever you want. A box, a variable, doesn't matter to me. Now number 4 says ln. That means natural log, right? So what's our understood base? E, right. So for natural logs, our base is e. So if we use that rule from yesterday about rewriting, I'd have e to the x, right, is equal to what we were taking the log of, which was e to the 4th, right? So x has to be
4.
perfect. Easy enough, right? So that's just kind of using our rules from yesterday. Okay. So we've got on number 5, 10 to the exponent log understood base 10, even though they didn't put it there, of x equals, we don't know, right? A box or x, whatever we might think. All right. So the base of this exponent is 10, right? So let's start first by just turning this into a logarithm, okay? So the base is 10, okay? So it would be the thing that is the exponent, kind of, right? This part. Remember yesterday we said the exponent was y when we were coming up with the inverse. So that part, which is log, we said understood base 10, even though they didn't write it. You can put it in there if you want, of 6, right? Is supposed to equal, we would write log of the base. What was the base? 10, of what the other side was equal to, which we said it was equal to x. Okay, so this is one of those rules that we just had on the front, right? Log of this common base 10. This is like your m, this is like your n, right? So that was rule number 3. So if we have logarithms like this, then we know m equals n. So what equals what?
X equals 6.
Right. Basically, you get to ignore the logs and set the other stuff equal to each other. Kind of like with your exponential functions. When we got a common base, you ignored the bases, right? You cross them out. You set your exponents equal to each other. So same kind of rule here. Okay. All right. Next one says express y in terms of x. Okay, that's just a confusing way of saying get y by itself or solve for y. So this just means solve for y or get y by itself. So that's going to be what we try and do here. Our goal is to get y by itself. Okay, well, if I'm trying to get y by itself, what do you guys think that we should maybe do first?
Subtract 1/2 log x.
Okay, let's do that. So I'm going to subtract 1/2 log x. And we know if we do it to one side, got to do it to the other as well, right? So over here, those cancel out because we subtracted them. And now we've got log y is equal to log of 3 minus 1/2 log of x, right? Okay, well, looking at this, you guys know any rules from the front we could maybe use to rewrite any of it? The subtraction could be, okay, so let's do that. We'll start there. So I'm going to have log of y is equal to log of what divided by what?
3 over x to the 1/2.
Very good. So we also use that rule of knowing that a coefficient can be rewritten as an exponent, all right? Okay. Well, now this is kind of like the same rule, right? We've got the log of an understood base 10 of something equals log of an understood base 10 of something else. So again, that makes this like m and n, right? So what do I know? So I just ignore my logs, right? And I now have y is equal to 3 over x to the 1/2, which is what they asked us to do, right? Get y by itself. Now, kind of like we said on the front, if x was something you could actually take the square root of, you would try and do so. But here, even if I rewrite this as 3 over square root of x, it doesn't change the value, right? I can't simplify any further. So these are basically the same thing. So either one of these answers would suffice. Okay. All right. Next one says we're going to use that change of base formula. So the formula from number 5. And it says, number 7 says to change the base to 2 and then simplify without a calculator. All right, well, let's flip back over and look at what that change of base formula was. Okay, so again, the change of base formula says whatever your base was, you can change it to whatever you want it to be. All you need to do is rewrite it as a fraction, and m, the part that was right here, goes to the numerator, and b, your original base, goes to the denominator. Okay? So, back here on number 7, they said they want us to change the base to be what? 2. So, that's exactly what I'm going to do. I'm going to change the base to 2, but if I'm going to do change of base, I have to make it a fraction, right? So, I'm going to put this over the exact same log with the exact same base. All right.
How does that make it 4?
It doesn't.
It doesn't?
No. So we've got m, which is supposed to go to the top. What's our m? 8. So the 8 goes here. All right. Okay, and then what goes to the bottom? The original base, our 4. And now these two separate logarithms are equivalent to the one that we started with. So when you actually divide these logarithms, you get the same answer, okay? Now, quick reminder though, this is kind of like what we were doing yesterday, right? I got a logarithm in the top, I got a logarithm in the bottom. So these are not equal, so I can't just cross out the logs, right? There's no equal sign in between them. What I can do is say, okay, I'm going to kind of ignore everything below the line, right? Right now, I'm just going to concentrate on the top, okay? Well, according to yesterday, I can rewrite this as the base, which is raised to the x power, right, should equal what? 8. So what power would I raise 2 to be 8? Okay, so that means the top here is actually equivalent to just 3. Okay, now I'm going to do the same thing in the bottom. Okay, I'll say this one equals y so that I'm using a different variable. Okay, so from yesterday, 2 to the y equals 4, right? So what value of y would make this true? 2. So apparently the denominator of our fraction is equivalent to 2. So this ends up simplifying down to 3 over 2. Okay? Yep.
Does changing the base, does that change the value too? Or does it just change how you solve it?
No, this is equivalent to this.
Okay.
That's why we had to turn it into a fraction, because I can't just change the base out of the blue, right? I couldn't just change it to a 2. But this formula makes it equivalent to what we started
You
with.
can change it to whatever.
Yep. As long as you use that formula. All right. Okay. Number 10 says for this one, it's not going to work out so nice and neat that we would get that 3 over 2. So it says we can use a calculator on this one. But we are going to use the change of base formula first. All right. It does not say what to change the base to, but if I'm putting it in the calculator, I probably want the base to be what? 10, right? Because that calculator button does an automatic base of 10. So let's do that. Let's change it to have base of 10. So it's going to do that in the top, and it's also going to have a log base 10 in the bottom, right? All right, so m goes to the top. What's our m? 9. And our old base goes to the bottom, which was 2. And then we just type that in our calculator, okay? So to get a fraction, you do alpha y equals enter. And then remember where the log button is in that far column over there. Probably is going to give you a decimal. Anybody tell me what decimal value you got?
You could also go to
3.169.
Good. 3.169, 3.17, wherever you want to round to, okay?
that's a lot.
All right.